is Nnamdi Nwulu. I'm the director for the Center for Cyber-Physical Food, Energy and Water Systems at the University of Johannesburg. The Center for Cyber-Physical Food, Energy and Water Systems at the University of Johannesburg is committed to leveraging 4R technologies, right, in improving the management of food, energy and water resources, right? And then we'll just be detailing a key project that we are working on amongst other projects in the center. Now this is a project that essentially tries to develop a smart agro-processing facility for rural agro-processors. Essentially we are developing a system that leverages machine learning, artificial intelligence, IoT, computer vision, blockchain technology, amongst other technologies for these rural agro-processors. The specific case study we'll be using will be the production of Amasi and Mahewu. So essentially we would use these technologies and measure various parameters during the fermentation of Amasi and Mahewu, and all of that information would be collated and put on the blockchain, and then AI and machine learning would enable us to create reports and then get a QR code that you can scan the product, and then you can now get relevant information about the product. Taking together these technologies would ensure now that consumer confidence is increased concerning the production of these technologies, and then rural agro-processors will be able to access the wider market than they would normally have been able to do.
Welcome to our demonstration of cutting-edge technology in producing Amasi, South Africa's traditional fermented milk product. Today, we're showcasing two innovative methods to transform how we monitor the fermentation process. High-resolution cameras are mounted above the fermentation vessel, capture images in real time. We also implemented specialized EC electrical conductivity sensors directly in the fermentation vessel. These sensors measure electrical conductivity, which correlates directly with the milk's acidity. Our advanced image processing algorithms analyze visual changes in the milk in real time. During the processing of Amasi, we get tons of data. These data include those from the fermentation process. We also get data from the water quality process. We can do quite a lot with these data. We utilize Theto AI built by the center to analyze sensor parameters for both water quality and fermentation in real time. These analyses generate a customizable PDF report which include parameters like product QR code and tracking ID, temperature, dissolved oxygen, turbidity, conductivity, and ferment dates, etc. This system is very smart, offering parameter invalidation for any input that is not useful. It also generates a QR code and barcode, which can be used both by AI and hardware scanners to scan and track the product across the supply chain. Now, let's demonstrate our verification process. Watch as I scan this Amasi product using our barcode scanner. Notice the confirmation beep. This indicates successful scanning. With a simple click on Verify, we can access blockchain contract ID, transaction ID, complete parameter history. Let's verify this on the Hedera blockchain. By copying the transaction link to the HashScan Explorer, we can see this product's journey's complete, immutable record. Now for something truly innovative, our computer vision system. Notice how the AI tracks facial movements and hand gestures. This creates a bridge between the physical and virtual worlds. We can interact with the interface by bringing our thumb and index fingers together. Watch as we scan the QR code using just hand gestures. The system recognizes these movements and responds accordingly. Now that the QR code has been scanned, it gives us a prompt telling us the QR code scan was successful and data processed by the AI are now available. We can now interact with this virtual world. Watch as I click on the virtual world and get responses. I can not only use my right hand, but I can likewise use my left hand. Let's take it to yet another level of innovation. Our SITEM can perform real-time data analysis of parameters. Let's put it to the test. Watch as I plot a bar chart with different colors, interact with the charts, and get average of temperature all in real time. Our system also features voice command capabilities, which are perfect for busy production environments where hands-free operation is essential.
Explorer.
Opening the Explorer now. Kindly be patient while I initialize window. You are now exploring CCP-FEWS #scan report.
So this project is one of the many projects that we are currently involved with at the center. At the moment, we are about deploying the demonstration you have just seen with colleagues from the Department of Food Technology, Biotechnology and Food Technology, and the Department of Transport and Supply Chain Management, that's Professor Adebo and Dr. Taba respectively, with a group of emerging agro-processors in Limpopo called the Limpopo Emerging Agro-Processor Program. So it's essentially a shared facility that will enable rural agro-processors to produce their agro products in a smart, controlled environment, and then they would now be able to leverage all of the technologies you have just seen to ensure now that there is increased consumer confidence, and then they satisfy all the food safety regulations.